Welcome to another session in a series of tutorials in R for data science. And today's session, we continue with our hypothesis testing, whereby we have looked at the chi-square and the z-test. So this is our last session in hypothesis testing, whereby we are looking at chi-square. We're looking at chi-square, and in chi-square, what we are looking at, or what we are looking on chi-square, is that we are testing the proportion, or we are focusing on categorical variables or factors in R. So you're saying, is the proportion? The question that you are asking is, because the basis of understanding hypothesis testing is understanding the question, what are you looking for, or what are you interested in the data set. So in a chi-square test, we are asking, is the proportion of certain categorical variables the same? Is it the same? For example, in this data set, we are asking ourselves, is the proportion of fair, good, cut, premium, and ideal diamonds, or this is from the diamonds data frame, or it's from the diamonds data set that comes with the ggplot. We are asking ourselves, is the proportion of fair, good, very good, premium, and ideal equal at a certain significance level, at a certain alpha level? We are testing that hypothesis. So our null hypothesis will be the proportion of all these cuts of diamonds is equal. The proportion is equal. And then the alternative hypothesis is that the proportion of these flowers is not equal. So that is the goodness of fit test. That's the chi-square goodness of fit test. Then there's another one, which is the test of independence. And in test of independence, we have two categorical variables. We'll be having two categorical variables, whereby we are saying, do these two categorical variables depend on each other? The question we're asking ourselves is, can we predict fair diamonds, good diamonds, very good diamonds, premium diamonds, ideal diamonds, given another categorical variable? So let's look at the data set that we will be using. The data set that we'll be using is the diamonds data set. So we first will be working with the tidyverse package. So we have to install using the install.packages. So you will install the library tidyverse. So you have to install this package called tidyverse, but because I've installed it, so I don't need to install it. I have to comment that. Then I have to load the package using library command function. That is library tidyverse. So we start with the goodness of it. So what we're asking ourselves is, let's first of all see the data set. Let's use the head command. Today let's use the tail command, and the tail diamonds. It will give us the last 6 values, and here it is. Now what this one is telling us is what we are asking is the proportion of premium, ideal, good, very good, is the proportion of these categorical variables equal? Are they equal, really, or is just a sampling error? That's the question we're asking ourselves. So we'll test this at 95% significance level. So we'll use the dataset diamond, and what you're interested in is the cut column, this column. So you're saying I'm creating a new dataset called tab. So I'm calling it tab for table data. So tab, I'm assigning this. I'm using the table command, and the table command will generate the count of each cut value here. So I'm saying tab, I'm using the table command. What this table command does is that it will take this column, this cut column, it will take this cut column, this one, then it will group, or it will count the number of premium diamonds, it will count the number of ideal, it will count the number of good, the number of very good, and all the values here. So let's run that. Let's see how this table looks like. Let's run that, and there it is. So it is giving us the proportion of each cut. So it's saying that fair is 1,610, good is 4,906, very good, premium, and ideal. So what we are testing is this proportion the same? Basically, if we look at it, they are not the same. But can that be a sampling error? So we have to test it statistically at a certain significance level. So we define our hypothesis, whereby you say our H0, that's the null hypothesis, the proportion of cut is the same. So the proportion of fair, good, very good, and ideal is the same. And the alternative hypothesis is that the proportion of the cut diamonds are not the same. So we use the chi-square dot test to perform chi-square. So I'm saying chi-square dot test. So I'm performing chi-square test on this data set called table. Let's run that. And there it is. Another way to perform a chi-square test is using chi-square dot test. Then I'm using the table command. So it's from here up to here. So it's just you can create an object called tab, or you can directly use this. So if we run this, it will be the same as this. Now let's interpret this in terms of our hypothesis testing. What's our p-value? The p-value here is 2.2 times 10 raised to power negative. It's a very small value. So this value is less than 0.05. Now, if the p-value is less than 0.05, we reject the null hypothesis. Now, we are rejecting that the proportion of cut is the same, and we conclude that the proportion of cut is not the same. So the proportion of cut is not the same. So that is the chi-square test. The chi-square test for independence, or for goodness of fit. Sorry, that's the chi-square test of goodness of fit. Now let's look at the chi-square test of independence. Now let's look at this data set called diamonds once again. Here it is, and here it is. Now, what you're testing in chi-square test of independence is I'm testing, given the cut of diamonds, or is a cut and color of these diamonds dependent? Can you predict what the other, given the other one? Can you predict cut given the color of that diamond? Or can you predict the color given the cut? So that is what we are testing. Are they dependent? Are they independent? So our null hypothesis is that the diamond's cut and the diamond's color are dependent. That is, they depend on each other. Given the cut, you can predict the color, and given the color, you can predict the cut. Then the alternative hypothesis is that the diamond's cut and color are independent. They are not dependent. They do not depend on each other. So I'm using still the table command, table, diamonds and cut, and diamonds and color. Let's run that. You see, and here it is. So the diamonds that have the cut fair and color D, this is their number. The number are the diamonds that are good, that have the cut of good and have color D is this, and you continue until the diamonds with the ideal cut and their and their color is J is 896. What we are asking is, given the cut, can you predict D? Are they dependent? Are they dependent or they are independent? So I'm creating an object called chi-square, chi_sq, and I'm still using chi-square.tTest. I'm saying chi-square of this object here. And if I run this, let's look at this. That is it. Let's look at that. The p-value is very small. It's less than 0.05. So that means we reject the null hypothesis. The null hypothesis was stating that diamonds and cut are dependent. So we reject this hypothesis and accept the alternative. So we accept that the diamonds, cut, and color are independent. So that is all on chi-square test. Chi-square test for dependence or independence. So we have looked at chi-square, we have tested goodness of fit, and chi-square test of independence. Thank you. We'll meet in our next class. Enjoy learning.